Question number 4. A ball of mass 250 grams connects to one end of a 30 cm long string. A student holds the other end of the string to make the ball rotating with uniform speed 0.8 meters per second in a horizontal circle on the table. Find the centrifugal force acting on the ball and state the origin of this force. Part B, if the maximum force that the string can withstand 承受 is 100 Newton. Find the highest speed that the ball can rotate. From the diagram, we see that the radius of the circle is equal to the length of the string. Next, there is only one force acting on the ball along the horizontal plane, which is the tension of the string. And tension is points towards the center. Therefore, the centrifugal force in this example is equal to the tension. By equation, we have centrifugal force Fc equal to mass times centrifugal acceleration, which is equal to m times v squared over r. Substitute the value. M is 0.25 kilogram. V is equal to 0.8 over r is equal to length, which is equal to 0.3 meter. Therefore, the centrifugal force is equal to 0.533 Newton. For part B, we have the maximum force that the string can withstand is 100 Newton. That means the maximum tension is equal to 100 Newton. That means the maximum centrifugal force is equal to 100 Newton, equal to mv squared over r. That is 0.25 times maximum speed v squared over r is equal to 0.3. Therefore, we have the maximum speed equal to 11.0 meter per second. Question number 5. A private car of mass 1,500 kg moves with circular motion at a speed of 60 km per hour or on a horizontal road. The distance of the car from the center is 20 meters. Find the centrifugal force of the car. State its origin. Part B, if the speed of the car increases, explain why the car will eventually skid 跣胎. Part A, centrifugal force equal to MAC equal to mv squared over r equal to 1,500 times v is 60 km per hour, change it to meter per second, divided by 3.6 v squared, okay, v squared, we have this v squared, over r is equal to 20. Therefore, the centrifugal force acting on the car is 2.08 times 10 to the power 4 Newton. And this centrifugal force is provided by the friction acting on the tire on the car. This is the friction. Okay, the friction is the origin of this force. And the friction is directed towards the center of the circle. Therefore, we can say friction equal to mv squared over r, because Fc equal to friction. For part B, since friction has its maximum value, therefore the maximum friction equal to mv square maximum speed square of maximum speed over r. Imply we have a maximum speed. Okay? If the speed of the car v increase steadily to the point v is larger than the maximum speed found from this equation, then the car will skid 跣胎 because there is insufficient friction to provide such a large acceleration. Question number 6. The moon rotates around the earth with a period of 27.3 days, and distance between the moon and the earth is equal to 3.84 times 10 to the power 8 meter. Find the angular speed and linear speed of the moon. Using equation, angular speed equal to 2 pi over period equal to 2 pi over 27.3 days turns days into second. We have 22. One day has 22 hours times 60 minutes times 60 seconds. Okay. Therefore, the answer for angular speed would be 2.66 times 10 to the power negative 6 radian per second. Linear speed v equal to omega r equal to 2.66 times 10 to the power negative 6 times r is equal to 3.84 times 10 to the power 8. We have the linear speed equal to 1.02 times 10 to the power 3 meter per second. Number 7. The Earth rotates around the Sun with a period of 365 days, and the Earth is at a distance of 1.5 times 10 to the power 11 meter from the Sun. Find the centripetal acceleration and centripetal force on the Moon. We have AC equal to omega square r equal to 2 pi over period square times radius, and centripetal force equal to MAC. Substitute the data into the equation. We have centripetal acceleration equal to 3.43 times 10 to the power negative 12 meter per second square. Also, mass of the Earth equal to 5.98 times 10 to the power 24 kilogram. Therefore, Fc equal to 1.5 times 10 to the power 7 Newton.